trying to calculate the moment. And what does the moment mean physically? The rotation, right? The rotation of something. So we're applying some force at a distance, and we want to know what kind of rotation this body is going to experience. In the end, it's a statics problem, right? In the end, you have a statics course. So we're going to want the rotation to be what? 0. In the end, we're going to want the rotation to be 0. But we have to first be comfortable calculating what the moments are. So right now, we're getting values for moments, which means these things are trying to spin. Okay? In the end, this bar, the system of bars here is connected to the floor, right, in some manner, some kind of connection. We haven't learned a lot about connections yet. So that's what's preventing it from spinning. So when we calculate a moment of negative, let's say 1700 kilonewtons millimeter, this connection right here has to withstand that. Because if it doesn't, it's going to tip over. Okay? So let's just go back and look at this problem. So the notation, we want to make sure that you're comfortable with the notation. This represents what? The moment about point O due to F1. So let's take a look at F1. We didn't know the perpendicular distance from F1 to point O, and we didn't feel like figuring it out. So instead what we did is we broke up F1 into X and Y. So we have F1X right here, and we calculated what that was. It was 5 cosine 45, and it's going to the right. And then we calculated what F1Y was, which was also 5 cosine 45, and it's going up. And so let's start going around. Let's start Chris. Z, start with you. So F1X, it's going to create what kind of moment about point O, positive or negative? Negative. So let me see everybody's hand. Right hand, fingers go in the direction of force, palm goes towards point O. We're going to get a negative value because it's going clockwise. And what would be the perpendicular distance, Iliad? So whatever the value of F1X is, what is the perpendicular distance to point O?
500.
500, right. Everybody sees this orange line. This is the line of action of the force. And this is the point in question, so this is the perpendicular distance. F1X times 500, and we found out, Chris said that it would be a negative value. What is the moment, Eric W.? What is the moment about? It's about this point, right? But how is it spinning? Is it spinning around the x-axis, the y, or the z?
Z.
It's spinning about the z-axis. So remember back to cross product. What does cross product mean? Do you remember what you were actually calculating? If you cross vector A with vector B, right, it'll give you a vector that's perpendicular to those two vectors. So vector A cross vector B will give you a vector that's perpendicular to both A and B. Does that make sense here? Our first vector is a force vector going in the x, and the distance is in the y. If I'm crossing an x with a y, what's the axes or the direction that's going to be perpendicular to x and y? Z. Right? Okay, let's look at the next one. So Brandon, we have F1y going here, right? It's going up. What is the perpendicular distance from F1y to O?
300.
300, right? And does it create a positive or a negative moment? Let me see everybody's hand. Right hand up, palm to the left, it's a positive. So it's a y value of the force times an x distance. What's the moment going to be about?
Z.
The z-axis. Everybody got that? Okay, let's go to the next one, JJ. So now we have F2, but again, we didn't feel like figuring out the perpendicular distance. We broke this force into components. Here's F2y, and where's F2x? Well, this is F2, the direction of F2x as well. So we have F2x in the orange. What's the perpendicular distance, JJ, to point O?
500.
500. Is it positive or negative?
Negative.
Negative. The force is in the x, the distance is in the
Y.
y, the moment is about
Z.
z. Armando, how about F2Y? It's going down here, right?
Yeah.
What's the perpendicular distance between F2Y and point 0? Or
300.
O? Say it again?
300?
300, right. And F2Y is in the Y. The distance is in the X, so what's the moment about?
Z.
The Z. And is it positive or negative?
Negative.
Fingers go in the direction of force, palm goes towards O, it's negative. Okay? So we took each component of F1X, F1Y, F2X, and F2Y, multiplied it by the perpendicular distances, and in the end we got a value of 1697. Show me with your hand which way it's spinning. Is it spinning clockwise or counterclockwise? Counterclockwise, why? Because there's a negative here, right? When the thumb points out, it's positive. When the thumb points in, it's negative.
So that's clockwise.
Oh, sorry, did I just misspeak? Yeah. Okay, so clockwise, just stop me on those
In my
things.
head there.
So clockwise, if the thumb's going in, it's negative. If the thumb's coming out, it's positive.
Along the negative z-axis.
Along the z-axis. So you would, if we have the x, the main x-axis here, and the y-axis here, so where would you expect the z-axis to be? Out of the board or into the board? I'm sorry, not the moment, I'm talking about the positive z-axis.
Out to the board.
If you have the x positive to the right and y positive up, z is supposed to be what? Coming out at us. So think about that. If your thumb is pointing in the positive z, it's a positive moment. If your thumb is pointing into it, it's going in the negative z direction. Everybody get that? Okay, I think you're comfortable. Let's do a 3D one. All right, then we'll come back and do vectors. So, let's do one that's not, it'll get a little complicated as we go along. Should we do one on the workshop? Let's do that one. So the workshop, so you wouldn't have the workshop one though in the packet, right? It would be, somebody is in the packet, or would it be enough to print it out on the website? This is what it looks like. You have it on you or no?
I printed it out. I have a copy.
Okay, so some of you printed it out already. Should I use this one or should I pick a different one?
It's not in the packet, sorry.
Yeah, no, it's not. Let's just do one of these, because I think this one's clearer than the next one I was going to pick, and I'd like to do an easier one first, and then get harder. So let's just look at the first one. So let me zoom in. Okay, so write down in your paper where you're getting this from, right? So this is the first, this is workshop, is it 4 or 5?
5.
5, I think it's a 3D one.
This is 3, this is 6, isn't it?
Let's see.
That's not working.
Yeah, it's 5, it's workshop 5. So right now, we're looking at the first problem in workshop 5. First problem in workshop 5. And I'm going to set up a table. I always like tables. I think most engineers like tables because we like things to be graphical. What units are we looking at? Inch, pound? looking at the force, which is 150 pounds. Okay, if I want to find, everybody look over here, if I want to find the moment about this joint due to this force, and I put this force at this joint, what moment's going to be created? No moment, there's no lever on, right? The only thing I could do to this joint with this force is move it in a translational motion. I can't rotate it. But if I apply the force out here, I could cause rotation, right? Because now we have a lever arm. So one situation that there is not a moment caused is when the moment goes through the point in question, right? Let's take a look at the situation here. We're looking at only the 150-pound force. The other two guys you're going to do. So we're looking at this 150. And the problem asks us to find the moment about the x-axis, the y-axis, and the z-axis due to this 150-pound force. So we're going to look at each of these axes separate. So I'm looking at this 150-pound force, and what direction is it going in? It's going in the z direction, right? It's going in the z direction.
Positive.
And it's in the positive direction. Let's take a look at this x-axis. So even though this is a 3D problem, I can look at it in 2D. Remember in graphics? Oh, those of you who took graphics, is this drawing here an oblique 3D drawing or an isometric? It's an isometric, because all these angles are the same. This is what is that? That would be 360 divided by 3. What's 360? 120. So this is 120, 120, 120. This is all, it's an isometric. So what I'm going to do is, this is the left side of my isometric, right? So when I look at it this way, I'm looking at it as a front view. And if I'm looking at it from over here, it's the right side view. So I'm going to look at it, I'm only concerned right now with the 150-pound force in the x-axis. So I'm really trying to reduce this in my eye, in my head, as even though it's a 3D problem, a 2D. So we're up to Chris. Chris, can you see the perpendicular distance between the 150-pound force and the x-axis? So there is a perpendicular distance. So let's try a different way. I'm trying to find. We know that the force is.
It's 30, right?
Say it again.
30 inches.
Yes, 30 inches. That's correct. Okay, so let's look at it a different way. We know the force is in the z-axis, and we're trying to find the moment about the x-axis. If we say r cross f is equal to a moment, and you already told me that this value has to be perpendicular, than both of these. Our force is in our z, right? The moment is in what, Chris? What moment are we trying to find? In the x. If the force is in the z and the moment is in the x, what is the distance going to be in? The y. Because x is perpendicular to both y and z. Did everybody see this, right? The rule is when you do a cross product, the solution to the cross product, the solution to the cross product has to be perpendicular to the two vectors, the direction of the two vectors. If r is in the y direction and f is in the z direction, the vector that's perpendicular to both y and z is x. Okay, so that's one way to think of it. The other one is to view it and look at it. If you have 150 and you're trying to figure out how it spins around the x-axis, the lever arm is going to be the 30 inches. Okay, should I explain that again? It's partly a thing, you gotta see it in 3D. Santiago?
So the distance from the force to the y-axis doesn't have any influence about the rotation on the x?
That's correct. So this force of 150, in order to create a moment about the x-axis, the only lever arm distance is in the y, which is 30 inches. So think about it is, if I held this axis in place and I applied this force, think about it as a pinwheel again. In order for it to spin about the x-axis, I have to use this distance. It would be 150 times 30 would create a spin about the x-axis. Okay, so the x-axis, we said it's 150 times 30 inches, and we're doing a right-hand rule, right? So it's the absolute value of the force times the absolute value of the distance, and then how do we get the positive or negative? What do I need to do?